So, hello, Assalamu alaikum, my name is Madhav, and today we are going to discuss about the matrices in mathematics. Okay, so this is second chapter of the math first year, and today we are going to do this. Okay, so firstly we need to understand some of the basic kinds of the matrices. Firstly we have rows. Firstly we have columns. What you say, rows or column doesn't matter, and rows. Okay, for example, you have one here and two, and you have one here and two. Okay, these things, this is called columns. Columns, and these are called rows. Okay, for example, you can see here, let me show you the example. For example, you have a matrices here, one, one, two, one, three, a1, two, one, a2, two, a2, three, a3, one, a3, two, a3, three. This is an example. Don't be confused. We'll discuss in the next videos as well. So these are called the rows. Okay, these are called rows, and these are called columns. All right. So there are some kinds of the matrices as well. Like for example, you can see here, this is a square. Okay, in square four sides are equal. Okay, as we know, but in the matrices we don't see like that. We see like rows and columns are equal. For example, I write here 2 comma 4, 6 comma 8. So two rows and two columns, so this is the same. Like for example, two rows, okay, and two columns, so this is the same. It like for example, you can see here, you can say c is equal to r, column is equal to rows. If you take an example of rectangle, okay, so what we're gonna do is we'll just put more elements in the rows. 2 comma 4 comma 6, 10 comma 20 comma 30. So you can see here there are two rows but three columns. So you can see, you can say that columns are not equal to rows. Okay, so this is an example. Now now what we are going to do is, we have, for example, you can say here, we have a diagonal. Okay, which an example, diagonal, you can say diagonal. And in diagonal you have already understood, I guess, which is also called linear. Okay, linear, I guess. Okay, one, for example, you can say here 1 0 0 0 3 0 0 0 5. Okay, so as you can see here, there are zeros in the up and down side, but in the middle, in the middle form, there are only like diagonal 1 3 5. This is called the diagonal form. Okay, this is called the diagonal form. Okay, for example, if you don't have 5, you have only 0, so it is also called diagonal form, no problem. If you have only 1 and there's 0, so no problem, it is also a diagonal form. But in this case there are two cases. Okay, second case is that scalar. In scalar you must have the same, what we say, same elements. Okay, for example, I write here 3 0 0 0 3 0 0 0 3. So you can see here 3 3 3, so these are the same, so this is called the scalar. Now there is one more condition about that. If you get only one, okay, I am talking about only one, okay, not the complete, only one. So if you get only one, so it is called free unit, vector unit, or identical unit, like this. Okay, it is compulsory. If you have here two, multiple two, like all twos are same in the diagonal form, so it is called scalar. But in the what the condition of one, so it will call the unit of free vector. Okay, let me write here, unit, free, or identical. Mostly people call it identical, so I prefer that to say. Okay, now we have another matrix, which is what we say, null vector. In null vector you have null, sorry, null, not null vector, matrices, null matrix. Okay, in null matrix you only have the 0 0 0 0 0 0 0 0. Let me write here 0 0. Okay, so this is called the null vector because it is not containing any kind of what we say elements except 0. Okay, so that's the thing. All right, so I forgot to tell you about the diagonal condition. There's a condition that you must have the zeros on the up and down side. 1 2 3 zeros here, 1 2 3 zeros here, otherwise it cannot be the diagonal form, it can be another form. Okay, and that is for today, guys. In the next video we'll discuss about the Hermitian, nilpotent, or what is, there are so many other kinds as well, and we'll do the solution as well. So I hope you understand all the things about today's lecture. Thank you so much.